Hello everyone, welcome back to my channel AWS DevOps Niche 11. So in this video, we are going to continue with the review of the practice exam questions for the AWS Architect Certification exam. And this video, we are going to cover the questions on design resilient architectures, right, as a part 2. So if you have not watched my part 1 video, where I have discussed about the questions on the design secure architectures, you can click on the link on either on the description of this channel, or you can also find the link above on the right hand side, which you can click and you can go through the contents. So this video, let us go ahead and see some sample questions on the resilient architectures. So basically, as I told you in my last video, we have 4 domains from which we can get questions on the certification exams. One is design secure architectures, which I have covered in my part 1 video. And today we will touch upon design resilient architectures. Then in the next video, I'm going to have some questions discussed on high performing architectures. Then we will cover the cost optimized architectures. Right? So today we will go through some 10 examination questions on the design of resilient architectures. Okay, so let me go back. Okay, so domain 2, design resilient architecture. So what do you mean by a resilient architecture? So resiliency is basically the characteristic where the application or the infrastructure can recover from failure as soon as possible, as quickly as possible. So this is a very important characteristic for the cloud computing, where the application should be able to get themselves restored to a normal condition from failures as quickly as possible. So from an architect standpoint, how we can design resilient architectures. So let us go through the first question on designing resilient architectures. A company needs to deploy at least 2 EC2 instances to support the normal workload of its application and automatically scale up to 6 instances to handle the peak load. So the architecture must be highly available and fault tolerant as it is processing mission critical workloads. So now what are all the keywords here? The company needs to deploy at least 2 EC2 instances. Okay, and it should be a highly available architecture. Now let's go through the options. So as the solution architect of the company, what should you do to meet the above requirement? So create an auto scaling group of EC2 instances and set the minimum capacity to 2. Then the second option is again setting the minimum capacity to 2 and the maximum capacity to 6. The third option is also talking about setting the minimum capacity to 2 and the maximum to 6. And the fourth option is saying create an auto scaling group and set the minimum capacity to 4 and the maximum capacity to 6 and deploy 2 instances in availability zone A and another 2 instances in the availability zone B. So I can give few seconds here for you to guess the answer. Okay, so I hope by this time you would have guessed the answer. So which is the highly available setup on these 4 options? So it is going to be the option number 4. This will be the correct answer. Why? Because we have to set the minimum capacity to 4 instances. How it is 4? Per availability zone, we should have minimum 2 instances running. So we will have 2 instances running on availability zone A, and we will have 2 instances running on the availability zone B. So that becomes the minimum capacity as 4. And they're also saying it should automatically scale up to 6 instances. So the maximum capacity should be 6. So we need to pick an option where the auto scaling group should have a minimum number of EC2 instances as 4 and maximum is 6. And secondly, we need to deploy 2 instances in each of the availability zone. 2 in availability zone A and 2 in availability zone B. Okay. So this is the correct answer. Setting the minimum capacity to 4 and the maximum capacity to 6. So if you see this diagram, here this is how we achieve a highly available architecture. For any availability zone, we will have two instances running. There will be a primary instance, there will be a secondary instance. So if the primary instance goes down, the secondary instance is available to serve the customer requests. Okay. So similarly, let's say in a worst case scenario, the whole availability zone goes down. We still have availability zone 2 running the third and fourth instances to serve the customer request. That is the reason we have to go for an option which has minimum 4 instances. Okay. And the maximum should be 6 instances. So this is how we can achieve a highly available architecture. Okay, now let me go to the next question. A solution architect is trying to enable cross-region replication to an S3 bucket, but this option is disabled. Which of the following is a valid reason for this? He's trying to set up a cross-region replication in order to synchronize the objects between source and destination buckets. But when he's doing that, the option itself is getting disabled. Why? Now, these are the 4 options we have. In order to use the cross-region replication feature in S3, you need to first enable versioning on the bucket. The cross-region replication feature is only available for S3 one-zone IA, or it's available only for S3 infrequent access. This is a premium feature which is only for AWS and enterprise accounts. Okay, so if you see, and the fourth is not the right answer. It's not like a feature that is available for enterprise accounts. Even for a free tier account, we will be able to create a cross-region replication. And it's not like it is available or restricted only for few storage classes. So all these options can be eliminated. This leaves us to the choice number 1, which is the correct answer. Okay, so for the cross-region replication to be configured for the buckets, versioning is the prerequisite. We have to enable the versioning on both the source bucket as well as the destination bucket. So what do you mean by versioning? So versioning is basically enabling the duplicate copy of the objects so that even when the object is deleted accidentally, they can be recovered back, right? So that is the primary use of the versioning. So for the cross-region replication, versioning is a prerequisite. Both on the source bucket, on the destination bucket, you have to enable versioning. So that is the reason choice 1 is the correct answer. We need to first enable versioning on the source and destination buckets. Okay, let's move to the next question. A logistics company plans to automate its order management application. The company wants to use a SFTP file transfer, okay, in uploading the business critical documents. And since the files are confidential, the files needs to be highly available and must be encrypted at rest. These are the other keywords, right? The file needs to be highly available. It also has to be encrypted at rest. The files must also be automatically deleted a month after they are created. So there should be a automatic deletion mechanism for these files, right? So basically, how can you automatically delete the files? We need to remember something called as a life cycle policy on the S3 bucket, right? So now let's go through the options. Which of the following options should be implemented to meet the company requirements with the least operation overhead? So these are the options we have. Create an S3 bucket with the encryption enabled, launch an AWS file transfer for SFTP to securely upload files to the S3 bucket, configure an S3 lifecycle rule to delete the files after a month. That is our choice 1. Choice 2, create an elastic file system and enable encryption. Configure AWS transfer for SFTP to securely upload files to the EFS. Apply an EFS lifecycle policy. So there is no such lifecycle policy as a EFS lifecycle policy. Delete the file. So let us go ahead and eliminate this answer. Similarly, this option, it is saying configure the retention policy on the SFTP server. Okay, so this is also something, we don't do it. We don't create any retention policy on the file server. Similarly, if you see the option 4, again, they are talking about EFS and adding a cron job to delete the files older than a month. But we do have a better option to handle this, which is choice number 1, which is meeting all the requirements here. Create an S3 bucket with encryption enabled, because they have said it's a business critical document and the file has to be encrypted at rest, right? So we can go with the default S3 encryption policy or the client side encryption policy and get the encryption enabled for the S3 bucket. Then we can also use this service, which is one of the service under the AWS transfer family, that is AWS transfer for SFTP endpoint. So we can use this service, get an endpoint to upload the file safely to the S3 bucket. And in S3 service, we do have an option to create a lifecycle rule in order to migrate the files from the active storage to the inactive storage and delete it after a specific period of time. So this option is meeting all the requirements that is given in the question. We have to enable encryption. We need to maintain the security for the files, and we need to delete the files automatically using a lifecycle rule. And that is why option 1 is the correct answer. Okay. So let us go through the next question. A suite of web applications is hosted in an auto-scaling group of EC2 instances across 3 availability zones. There is an application load balancer that forwards a request to the target groups. The scale-in policy has been triggered due to the low number of incoming traffic to the application, right? So whenever the scale-in is kicked in, on what basis, on what parameters the instance will be terminated by the auto-scaling group. So these are the options we have. The instances launched from the oldest launch template, the instance which has the least number of user sessions, the instance that has been running for the longest time, or the instance that is randomly selected by the auto-scaling group. So the default configuration of the auto-scaling group is whenever a scale-in is kicked in, it will either terminate the instance that is having a old launch template, or it will terminate the instance which is approaching the billing cycle or which is close to the next billing hour. Okay, so these are the 2 options based on which the instance will be terminated by the auto scaling group. So in these options, we don't have the billing hour or the instance which is close to the next billing hour. We have only the oldest launch template. So that is the reason we have to go with this as the correct answer. Okay, so the instance launched from the oldest launch template will be terminated by the auto scaling group. Okay, I hope this is clear. Okay, now let's go to the next question. A company plans to host a movie streaming app in AWS. The CAO wants to ensure that the application is highly available and scalable. The application is deployed to an auto-scaling group of instances in a multiple AZ. The load balancer must be configured to distribute incoming traffic evenly to all the instances, right? So which of the following should the solution architect use to satisfy the criteria? Okay, so we have 4 options here. So Amazon VPC IP address manager, cross-zone load balancing, path-based routing on AWS, direct connect. Okay, so let's go through the keywords here again. The CIO wants to ensure that the application is highly available and scalable, fine, or that they are using the load balancer. They are also using auto scaling group on multiple AZs. And the load balancer must be configured to distribute incoming requests evenly. This is very important. How we can enable the load balancer to distribute the incoming requests evenly to all the instances across multiple availability zones. So let's say you have availability zone A where we have 2 instances, and you have availability zone B where you have 8 instances. So the number of instances per availability zone is different. But in spite of that, how you can make the load balancer transfer the equal amount of traffic to this availability zone. So that is achieved by a configuration called as cross-zone load balancing. If you enable cross-zone load balancing, the load balancer will be able to distribute the incoming traffic to the instances evenly, although we have different number of instances across multiple availability zones. So cross-zone load balancing is the right answer in this case. Okay, so correct answer is the choice 2, cross-zone. You have to enable cross-zone load balancing on the load balancer. Okay, next question. A company plans to run a monitoring application on an EC2 instance. Connections are made to the instance using the private IPv4 address. A solution architect needs to design a solution that allow the traffic to be quickly directed to a standby instance if the application fails and unreachable, right? So they are talking about a private IPv4 address, and whenever there is a failure, the traffic should be quickly directed to a standby EC2 instance, right? So how we can achieve this? So deploy an application load balancer configured with the listener for the private IP and register the primary instance with the load balancer. Upon failure, deregister the instance and register the standby EC2 instance. This is one option. Second option is creating a custom DHCP option set. Third option is creating a secondary elastic network interface to the EC2 instance. Configured with a private IP address, move the network interface to the standard EC2 instance if the private instance becomes unreachable, right? And associate an elastic IP address with network interface of the primary EC2 instance. Disassociate the elastic IP from the primary instance upon failure. Now we can quickly eliminate some of the answers, because if you see, elastic IP is typically a public IP address, right? So here they are talking about a private IPv4 address. So this option cannot be considered. Okay, then they are talking about application load balancer and a custom DHCP option set. So custom DHCP option is also not going to work out in this case, because again it is going to allocate IP randomly, right? So we can eliminate this option also. Now it is between the application load balancer and the elastic network interface, and which is the best and the cheap option will be the option number 3. So what you can do is we can have the secondary elastic network interface. Basically on the primary instance, we can create two interfaces. One with the primary IP address, and there will be a secondary IP. So we know that ENI, in this ENI service, we will be able to detach the secondary interface from one instance and attach it to another instance. That is the reason it is called as the elastic network interface. So that is what we need to do here. We need to attach a secondary elastic network interface to the EC2 instance that is configured with a private address. Then move the network interface to the standby EC2 instance so that the IP and all the other networking attributes get shifted to the new instance. And this is the best way to achieve this option, right? So choice 3 is the correct answer. Correct answer is C. Okay, let's go to the next question. A company runs an online voting system for a television program. During broadcast, users submit hundreds of thousands of votes within minutes to the front-end fleet of EC2 instances in auto-scaling group. The instances write the votes to the RDS database, right? So the votes are being written into the RDS database. However, the database is unable to keep up with the request which is coming from the EC2 instance. The architect must design a solution that processes the votes in the most efficient manner and without the downtime. Which solution will meet this requirement? So migrate the front-end application to a Lambda. Use the API gateway to route user requests to the Lambda functions. That is one option we have. Scale the database horizontally by converting into a multi-AZ deployment. Configure the front-end application to write both to primary and secondary DB instances. Configure the front-end application to send votes to an SQS queue. Provision worker instances to read the SQS queue and write the vote information to the database. Using the Amazon event bridge to create a scheduled event to reprovision the database with a large memory optimized instances during the voting periods. Okay. So here, a solution architect must design a solution that processes the votes in a most efficient manner, okay, and without a downtime. So, which is a service that will help in decoupling the applications and will minimize the downtime. So that should give us a clue. It should point to the SQS, because SQS is application which is used to decouple your sending entity, that is a sending component of the application, and receiving component of the application. Right. So in this case, what is the best way to handle this? Configure a front-end application to send votes to the SQS queue. So we create a SQS endpoint and we will configure the application to send the votes to the SQS queue, and we will provision the worker instances, which is the receiving component of the application, to read the SQS queue and then process it, then write the information to the database. So this way, there is not going to be any downtime, because each and every request will be stored in the SQS queue. And although your sending component or the receiving component of the application is down, still the messages are preserved in the SQS queue. That is, the votes are preserved in the SQS queue. That is the reason this is the best way to handle this requirement. Okay. So configure a front-end application to send votes to the SQS and provision the worker instances, that is the receiving component of the application, to read the message from the queue and then send it to the backend database. Okay, so correct answer is C. Okay, so now let's go through this question. A company has a two-tier application architecture that runs in the private and the public subnets. So EC2 instances are running the web application, which are in a public subnet, and there is a database running on a private subnet. Okay. So which common, and they are running in a single availability zone. You can see here, they are running in a single availability zone. Which combination of steps should a solution architect take to provide high availability for this architecture? So this itself is a keyword. Single AZ, it should not be in a single AZ. The solution should basically spread the infrastructure across multiple availability zones. So this should be a keyword for us. So we have to go to the app option, which is somehow saying that the solution should be across multiple availability zones, right? So let's see which is basically close to this multiple AZ. Create a new public and private subnets in the same AZ. Again, this is not going to achieve high availability. Let's exclude this. Create an Amazon EC2 auto scaling group and application load balancer spanning multiple AZs for the web application instances. Yes, because we have a web tier and a database tier. So how do you achieve a high availability for your web application? By definitely using a application load balancer and the auto scaling group. So this looks to be one of the correct answers, because we need to select two answers, right? So this is one of the correct answer. Now add the existing web application to an auto scaling group behind the application load balancer. So anyway, web thing, we have already covered it with option 2. So this can be eliminated. Create a new public and private subnets in the new AZ. Create a database using an EC2 instance in the public subnet. No, we never create a database in the public subnet, right? Database should always be created in a private subnet. So this option also can be eliminated. So this leaves us with option 5. Create a new public and private subnets in the same VPC. Yes, each in a new availability zone. Create an Amazon RDS multi-AZ DB instance in the private subnets. That's correct. Always a database we need to create as a multi-AZ deployment and it should be in a private subnet. Then we can migrate the old database functions to the new database. So this is how you achieve high availability for your web layer and the database layer. So option 2 is typically for your web layer. Okay. And option 5 is typically for your database layer. So 2 and 5, they are your correct answers. Option 2 and 5 are the correct answers. Okay, so that is B and E. Okay, so let's go to this question. A company has an application that uses multiple EC2 instances located in various AWS regions. You can see there are multiple regions coming up in the picture. The manager instructed the solution architect to set up a latency-based routing, right? So this itself should give you a clue. So where you will see this option, latency-based routing, it is actually one of the option under the Route 53 service, right? Route 53 service, it is basically a DNS service from AWS, and it offers various routing options, right? We have simple routing, we have latency based routing, etc. So now, so the manager should set up a latency based routing to route incoming traffic for this domain www.xyz.com to all the instances across all the AWS regions. How can we achieve this? Use a network load balancer to distribute the load. No, network load balancer is a region specific service, right? So it is not going to span multiple regions. So this can be excluded. And AWS data sync to distribute the load. Data sync is not a service to distribute the load. So we have to exclude this as well. Again, application load balancer is a region specific service. This can be included. So we need to pick a service which is a global service and which can span across the regions. And that is nothing but Route 53. So because they are also given latency based routing, which is a key word here, right? So the correct answer is choice 2. Use Route 53 to distribute the load to the multiple EC2 instances across all the AWS regions. Okay, because Route 53 being a global service, it can span across multiple regions. Okay, so the correct answer is B. So let's go to this question. As part of the business continuity plan, IT director instructed you to set up an automatic backup of all the EBS volumes for your instances. So what is the fastest and most cost-effective solution to do it? So basically, in this case, I think we'll have to go for a managed service that will help in automating the creation of the EBS snapshots. So using a EBS lifecycle policy in S3 to automatically back up the EBS volumes. For an automated solution, create a scheduled jobs that calls the create snapshot command via the AWS CLI, using the data lifecycle manager to automate the creation and setting up the storage gateway. So if you see the most cost-effective solution and how we can automatically handle this backup of the EBS volumes, we have to go ahead with a managed service, which is this one, using the Amazon Data Lifecycle Manager to automate the creation of EBS snapshot. So this service will help in automatically scheduling the creation of the EBS snapshot. Choice 3 is the correct answer. Okay, so correct answer is use Amazon Data Lifecycle Manager. Okay, so that's quickly the 10 questions on this module, design resilient architectures team. I hope you would have got some tips on how do you exclude the inappropriate answers and get to the right answers. And I hope this video was helpful. So now with this we are completing the domain 2, that is design of the resilient architecture exam questions. So I will meet you all in my next video where we are going to review some questions on define high performance architectures.